All right, the last part of 8.3 is on work, okay? How much work does it take to move something? There's two different ways you can do it. If you are moving something from here to here, okay, what you can do is you can take the projection of F onto AB, that's this vector here, and find its magnitude, times the magnitude of this vector. Or we can take the dot product of F and AB, okay? So there's multiple ways of doing it. The easiest way to just do it is to just take the projection of F onto AB, take the magnitude of that times the magnitude of AB. That's the easiest way to do it, okay? So you're going to take this times basically how far you're pushing something. So example 7 says a person pushes a car with a constant force of 120 newtons at a constant angle of 45 degrees as shown. Okay, so they are pushing at a force of 120 newtons at an angle of 45 degrees. Find the work done in joules moving the car 10 meters. So the magnitude of how far I'm moving it is 10. Okay. What I need here is I need the magnitude of this vector here. Well, if I draw a right triangle, all I have to do is use cosine. So the cosine of 45 is my projection vector over 120. So if I write that out, cosine of 45 equals the projection of F onto AB over 120. So then I can just multiply by 120. So then to find the work, I just multiply those two together. 10 times 120 cosine 45. Now, cosine of 45 is square root of 2 over 2. I could get an exact answer. I don't want my exact answer. So I'm going to use the calculator. 10 times 120 cosine of 45. And so in joules, which are known as Newton meters, okay, it's 848.5. Okay, guided practice 7. Rick is pushing a vacuum cleaner with a force of 85 pounds. The handle of the vacuum cleaner makes a 60-degree angle with the floor. How much work in foot-pounds does he do if he pushes the vacuum cleaner 6 feet? So again, I need this vector, the magnitude of this vector, and then times the magnitude of this vector, which is just 6. So this one, again, is also going to be a cosine. So I can write it out. Cosine of 60 is going to equal the projection of F on AB over 85, multiply by 85. So then to find my work, I take 6 times this. Now, cosine of 60 is 1/2. So I'm actually going to get a nice answer. 6 times 85 times the cosine of 60, 255 foot-pounds. All right, one more. This is another one that's not in your book, so you'll just have to listen. A person pushes a reel mower with a constant force of 40 newtons at a constant angle of 45 degrees. Find the work done in joules moving the mower 12 meters. So I again need this. We've gone through this a couple times now. This is just going to end up being 40 cosine of 45. So I'm going to take 12 times 40 cosine of 45. Again, cosine of 45, square root of 2 over 2, not nice. So I'm just going to plug it in the calculator. And I'll get 12 times 40 cosine of 45, 339.4 joules. So notice when this is in feet and pounds, it's called foot-pounds. If this is in newtons and meters, it changes to joules. This can also be called meter newton, just as like this is foot-pounds, this is newtons and meters, but this has its own unit. This is still called foot-pounds.